This conference will now be recorded.
All right, this is the quadratic equation function section where we had a few more graphing problems to do and also one more of the writing equations form. So this one, we're going to be trying to graph this using our techniques we learned in this section, which is we want to know if it opens up or down. We want to know the vertex. We want to know if it has any x-intercepts, y-intercept, and what is the axis of symmetry. Opens up or down just depends on the leading coefficient being positive or negative. So since it's positive, this will open up, which means our parabola should look like this. To find the vertex when you're in general form, you do x equals negative b over 2a. So that's negative 7 over 12. So that's the x value of that. Now, when we're graphing it, we obviously will care about maybe a decimal, but for the answer, you write the fraction. And then we're going to plug that back in to find the actual y value. So that's 6 times negative 7 over 12 plus 7 times negative 7 over 12 and then minus 24. So, and that's squared right there, by the way. That's going to be 6 times 49 over 144 plus negative 49 over 12 minus 24 over 1. Might as well go ahead and write that. I believe, does 6 go into 144? Let's check that real quick. So 144 should be divided by 6 is 24. So that's going to reduce and leave us with a 24 there. So now we need to get a common denominator of 24. So times this fraction by 2 over 2 and this one by 24 over 24. So that's going to make 49 over 24 minus 98 over 24 minus, what's 24 times 24? 576 over 24. So let's make that negative, subtract the 98, and then add the 49. That's negative 625 over 24. Okay. X-intercepts, we set the whole thing equal to 0 and see if we can factor it. So let's look at 6 times negative 24 is negative 144. And we need a pair of factors that make a 7 when we subtract them. So what is 9? If you divide by 9 and 16, so that makes 7. Yeah, I kind of had a guess on this one. So negative 9 and positive 16 will work. So this is 6x squared minus 9x plus 16x minus 24. Factor by grouping. That's going to be 3x, 2x plus, minus 3 plus 8 times 2x minus 3. So we get a 2x minus 3 and a 3x plus 8. Set those both equal to 0, and we get 3 halves and negative 8 thirds. So remember, those would be x-intercepts 3 halves, comma 0, and negative 8 thirds, comma 0. The y-intercept is easy. You just look at the constant when you're in general form, so that's 0, negative 24. And the axis of symmetry is the x value of the vertex. Okay, so in terms of graphing these, you probably want to estimate, and we can't, our graph's not even going to go down far enough because it only goes to negative 10. And we already know our y-intercept is negative 24, so this is going to be even lower because it's the vertex. So I'm actually going to change my scale to counting by 5s on the y-axis. So this will be negative 5, negative 10, negative 15, negative 20, negative 25. So same thing up here, 5, 10, 15, 20, 25. You can leave the x's alone as long as you're consistent on the x-axis as you are on the y-axis. So it just needs to count by the same thing all the way up and down. So let's see, where is 7 divided by 12? Because that is, and it's negative. So that's like negative 0.6. So negative 0.6 is going to be about right here. And then 625 divided by 24, and it's negative, is negative 26. So negative 0.6 and then down to negative 26 point something. So that's actually going to be right about here somewhere. Then 0, negative 24. So that's just a little bit above the negative 25. We have 3 halves, 0. So that's 1.5. We also have negative 8 thirds. So 8 divided by 3. So that's negative 2.7. So that's about right here. And I'm not really going to draw in the axis of symmetry because I made all those marks for the change in the y-axis. But I think, let me see, did I copy something wrong? No, that's okay. It just doesn't look like this E is evenly spaced on both sides. Oh, that's because I went too far on that side. I knew something looked a little off because you should have symmetry around that vertex. So let me see if I can find my eraser. There we go. It's not letting me do it. Because let's just check this real quick. See if I did something incorrectly with my factoring as well. Oh, it's positive 3 halves, which is 1.5. No, that's where I've got it marked. Okay, it's probably because I scaled this funny, but it just didn't look like this is the, I think I've got this over too far. That's what it is. The vertex wasn't looking as centered as it should have been in the middle. So sometimes these are nasty. Sometimes you get nasty fractions and you just have to work with them. All right, so let's look at the other one we skipped in class, which is E. Again, this one opens up because the leading coefficient is positive. Vertex, this one's going to be a little bit easier to find, not as nasty. So negative b over 2a is going to be 4 over 4, so that's going to be a 1. Plug in 1 for all of the x's to find the y value. That's going to be 2 minus 4 minus 11. That's 2 minus 15, so that's negative 13. X-intercepts. Now, in this scenario, I believe this one does not factor, so we have to do quadratic formula to find the x-intercepts. So that's going to be x equals negative b plus or minus square root. B squared would be 16 minus 4ac all over 2a. So in the middle there, we get a negative times a negative. So that's 80 plus 88. So 16 plus 88 is going to be 104. Which is got a perfect square of 4 inside of it. So square root of, let's see, divided by 4 is 26. So that's going to be 4 plus or minus 2 on the square root of 26 all over 4. So that reduces to 2 plus the square root of 26 over 2 comma 0 and 2 minus the square root of 26 over 2 comma 0. Now that's how you would write the answers, but when you go to graph it, you're obviously going to want decimals, so I'm going to write those underneath. So square root of 26, add that to 2, divide it by 2. That's 3.55 for that first one. And then we want to do 2 minus the square root of 26, and then divide that by 2. That's negative 1.55. Give it just a second. My pen got stuck. There we go, negative 1.55. Okay, y-intercept is just the constant value since we're in general form, so negative 11. And the axis of symmetry is at x equals 1, because that is our vertex x. Okay, so sometimes, like I said, you get some nasty points. This time it's because of the quadratic formula. So we need 3 more marks down here. So this is negative 11, 12, 13. So 1, negative 13 is down here. And 3.55 is about right here. Negative 1.55 is about right here. And 0.11 is the other y-intercept. This one's a little bit easier to map out the axis of symmetry. That's x equals 1. So we notice the graph is going to have symmetry across the vertex point. And again, my pen's not letting me draw these very nicely, but you get the general gist. And then the last one we skipped before my battery on my laptop dies is this one. They gave us two x-intercepts, and they said that the vertex has a lowest point of the y-coordinate being -48. And in class, we talked about how they actually did tell you the vertex x as well, because the vertex should be exactly halfway between these, so it's at 4. So remember, the rule is you use one of these points, so why not use 0, 0, since that's an easy point for an x-intercept. And we plug that.
This conference will now be recorded.